Hello everyone, I'm Jay, your host at Everything Cloud Platform. Welcome to this session on kubectl. Kubectl is the command line tool for interfacing with Kubernetes clusters. It serves as your main control panel for managing and deploying containerized applications within the Kubernetes environment. Essentially, it's your Swiss and Army knife for interacting with your Kubernetes ecosystem. Here are some key things that you can do with kubectl. You can deploy applications, define your application configuration in YAML files, and use kubectl to create and deploy to your clusters. This includes pods, deployment services, and other Kubernetes resources. You can manage your cluster resources like list, view details, update and delete various resources like pods, nodes, deployments, and service. You can also scale and roll out, do a rolling restart on your deployments. You can inspect the cluster states, like get insights into the health and performance of your cluster and applications. You can view logs, check resource usage, and get other insights. You can debug and troubleshoot problems. You can utilize commands like logs and describe to diagnose problems with your cluster and pod and containers. Well, a quick call out before we get into the agenda here. This is not a session on Kubernetes. If you are not familiar with Kubernetes and container orchestration, please refer to the Kubernetes session video. Here is the agenda for the session today. We'll look at how do you get into the GKE cluster, how do you set the context, and basically get connected to the cluster. I'll show you ways to help yourselves, right? It's important to teach you to fish rather than provide the fish. So we'll spend some time on seeing how you can help yourselves as you start using kubectl. We'll play a lot actually with kubectl get, because that's one of the most important commands that you will be using to really look at information and do your stuff with GKE clusters. We'll then deploy the apps using the declarative way, and that's the production way of doing things. We'll deploy apps in Nginx web server using imperative way as well. Some of those imperative ways are useful when you go about doing your CK-AD or CK certifications around. And lastly, we'll be looking at we'll be doing some troubleshooting by introducing some issues, errors in our cluster. We'll be doing some troubleshooting and seeing how you go about finding issues or doing the root cause troubleshooting for issues that you face with your cluster. So let's go. Before you do anything with kubectl, you will need to ensure that you are connected to a cluster. A, you have a cluster created, and B, you're connected to the cluster. I have a cluster created already and connected as well, but we'll reconnect to the cluster real quick here. But there's a separate session on creating a Kubernetes cluster and connecting to it. But here is the cluster that is already created. You can review the cluster details from here. And workloads, there are a couple of workloads. Our sample apps are running in this cluster already. The command to connect to the cluster is this. Once you submit this command, the gcloud container clusters get credentials command, you will see this message that tells you that, yeah, you were successfully able to connect with the cluster. Now, take a look at some of the kubectl context related commands that are going to be very important to understand here on what context are. Basically, say if you think about, you have multiple clusters, for example, or you have multiple GCP accounts, and each one of these are having a different kubectl or GKE clusters. So when you submit your kubectl commands, which cluster does that command runs against? And that's what the context means. These contexts, so we'll take a look at some of these commands. So if I run kcgc, which is the alias for kubectl config get context, so let me do a kcgc. That gives me a bunch of clusters here. So I keep using a lot of clusters. That's why you're seeing so many entries here. But you might not see all of those entries, right? You might not have anything in your setup so far. So just keep that difference in mind. But that gives you all the context so far. Now we'll look at the current context, right? That's what we are, that's what the kubectl commands will run against. So if I do a kccc, which is the alias for kubectl config current context, that will show me the current context. And this confirms, yeah, that's my current project. That's the region I created the cluster in. And SRE, that's the name of the cluster. So that's the current context that we are, we have in place here. Now you can absolutely delete the context, you can get the context and do all of that. You can, set a particular context, you can use a particular context there. So there are commands that you can use to change and switch the context that the kubectl commands will need to work on. So that's a little bit about how you go about changing and setting the context. Let's run a couple of quick commands like kubectl get ns. That's the get namespace command. That gives you all the namespaces. This ECP stands for everything cloud platform. That's our namespace. The others are the Kubernetes cluster, the GKE cluster related namespaces. Now, if I look at quick aliases and if I look for namespace, yeah, then KGNS, you'll find that KGNS is one of the aliases that I keep using to get the namespaces. That's what we'll use here to get our kubectl get namespaces. There is a switch called show labels. If I do a show labels, that gives you some of additional information around here. So that's how you go about seeing what's in the namespace. Now we'll get into some of the other details around how kubectl commands work, but I'm running one command to show you or do something here to show you what the default namespace is. If I do a kubectl get say deployments, this is supposed to fetch all the deployments in a particular namespace. Now look at the output that it gave us. It said no resources found in default namespace. It's looking for the deployments in the default namespace. So the default namespace is the default namespace that the kubectl commands are running against. And we want to change this to ECP. If I were to fetch the deployments for ECP, my namespace, I'll need to do something like this. -n, that dash n and ECP. Now it will give me the deployments that are in my namespace. But I want to make, since we'll be working mostly in ECP, I want to make ECP as the default. And for that, one of my aliases is KCN, and I'll show you the command. Basically, what you're doing is you're setting the context with the current namespace as ECP. So if I run this command, if I do a KCN, which is equivalent of this, so I do a KCN and provide ECP as the namespace there. Now the context is modified and the default namespace now is ECP. So now if I do a kubectl get deployment without the -n sign, I will still get the deployments from the ECP namespace. So that's how you go about modifying your context to change the default namespace to the namespace that you might be working in. One of the most important things I want to do in my sessions is to enable you to help yourselves. And a couple of things that I would point out from kubectl standpoint are these. Say kubectl version. That shows you the version you are on. That's one thing. You can run kubectl say cluster info. That gives you some important information around the control plane or the metric server of your cluster. So some important information that might come handy as you work in production environments on Kubernetes clusters. The other important is, like look for help for Linux commands or gcloud. You have that same feature available here as well. If I do a kubectl --help, you get a list of everything, all the commands that are available with kubectl. And there are some basic commands around creating a resource from a file or exposing a service, or running a pod, running an image on a pod, or explaining or getting a documentation for a resource, or doing a git and display one, or we will play around a lot with this one, for example, because that's one of the most basic commands that you'll use for a lot of your resources. We'll play with some of the deploy commands, as well as we'll roll out and scale our deployments. There are some cluster management related commands that you might need to get into. Not we are not going to be covering a lot of these. We just looked at cluster info already. There are some troubleshooting related commands. We'll look at a few of them, like we'll look at the describe, we'll look at the logs, we'll look at exec, and so on and so forth. There are some advanced commands as you work through Kubernetes in production environment. Some of these might come handy. So as you work through it, look at the help and figure out what you will need to do, and use the help accordingly. Here are my aliases that I have set up on my Mac, and you should set these up for you too. That will just make it easier for you to work through. It has a lot of Linux commands and some G-Cloud, and mostly it has a lot of kubectl commands that are also available right here for pod management, deployment management, and whatnot. If I just keep scrolling down, there are a lot of kubectl commands here that have the aliases defined, and these are available in the utilities repo in my GitHub account. And this is a public repo. You can readily download, just clone it, and have these aliases in your bash profile or Z profile, whatever you might be using, and you'll be good to go with all the aliases that you will see me using across these sessions. Let's now try and pull and extract information from our GKE cluster using the kubectl get. That's the most widely used command when you're trying to obtain information or interact with your cluster. So say, for example, we know that we have, if I do a get deployments, I have these two running, and I'll start using aliases here. I'll do a KGD for get deployments. I get the same output. So this gives you a standard output with some standard columns. That's how kubectl is designed to give you an update output in this format. Basically, this is telling you math functions has 5 pods running, and all 5 of those 5 are ready and up to date. Available are 5. Everything is going fine. If I do a quick and similarly, NumberWiki has 3 pods running. If I now do a KGP, which is the alias for kubectl get pods, you can very well run kubectl get pods here to get the pods. Now this is going against the ECP namespace. That's why you're seeing all the ECP namespaces pods. So you're seeing 5 pods for math functions and 3 for NumberWiki. That's how we configured our deployment YAMLs when we deployed these resources. Yeah, that's giving you the pods. There is also one more component that is deployed for these application, and that's services that can be pulled using this, and that's the external IP of NumberWiki. And if you do a quick curl just to test your application, yeah, the application is working. And if I test one more endpoint, that just quickly tells you how you go about in testing the application. But that's how we just pulled the deployments, the pod, and the services. That gives you an output in the tabular format like this. Now, what if we want our output a little more detailed? And that's what we are now going to do now. Say, for example, if I want to do kubectl get deployments, not just for our namespace, but for all namespaces, right? So that gives you all the namespaces output. So you have GMP operator running in GMP system, you have rule evaluator running in GMP system, and all of these are system Kubernetes GKE namespaces, right? And so this is giving you all of that information. We have set up ECP as the default namespace. Hence, if I just do kubectl get deployments, it goes against ECP and gives you the output for that. So you can go after the all namespaces. There are a couple of other switches like this that you should know. We already saw the show labels earlier. That just shows you, gives you one more column with the labels information. There is one more label called one more parameter that goes with no headers. If you run that, it just omits the header. If I run without that, you will see that you get the header here, but you did not get any header there with the no headers switch. Now, this is how you go about getting a quick output and interact with your GKE cluster. Now, we'll get a little deeper into a couple of other formats that you can get the output in. You can get the entire configuration for a deployment, pod, or a service in a JSON or YAML format. And let's look at those real quick here. Let's set a couple of variables here. App1 equals to math functions and app2 equals to number wiki. Okay, and if I do a kubectl get deployments, and if I provide say $app1 and minus OS for output and then JSON. Now this will pull the entire deployment for math functions in a JSON format. That's the output that you get. Now there's a lot of output that you can unpack from here. It basically is your JSON format blueprint for your deployment. And you'll be able to see this in the console as well. I'll show you a little bit right there. But it's good to get this information here because now you can programmatically do things. If you want to just pull, say, this piece out, there are mechanisms or ways that you can, pull this information out, and so on and so forth. And CLI, if you're troubleshooting, doing things, this some of this comes really handy. So that's your JSON format. What if I do a YAML format? That is a little more readable. If you are comfortable with YAML, go ahead and use that, but it's the same kind of output that you really get. You're seeing the metadata, you're seeing the labels, you're seeing the spec. And typically the high level sections are the API version, the kind, the metadata, and spec. Those are the four sections that you will typically see in any Kubernetes configuration YAML file, and this is how you build you deploy your resources as well, but that's for a different session, not for here. So that's your YAML output for deployment. So we just saw the JSON and YAML output for a deployment. What if I want to say pull pods? Now, of course, this will not work. Let's see why that will not work. If I pull my pods, you want to go after a specific pod that you want to go after. Say if I hold that pod name in a variable called pod. Now, if I do a KGP kubectl get pods and I provide that pod name and I do a -o JSON, I get the output and for that pod in a JSON format. Now there is a lot of system generated information in here, like this creation timestamp is capturing when was that pod created. Some of this label information is coming from the way this deployment was deployed, and so you are seeing some of this label information. But this is all the information that you have captured in the pod. And you can get the same output, say, in a YAML file, right? That's your YAML file output. And this is the pod IP, that's the host IP. There's a lot of information that you will be able to see in this JSON and YAML output format. Now we can do the similar thing for, say, KGS, kubectl get services minus services. Let me just pull both of these. Let's pull these services as well. So app1 is math functions, app2 is number wiki. Say if I'm doing a KGS and app1 and I'm doing a -o JSON, I get the output for that particular service in a JSON format. Similarly, I can get this as well in a YAML format. Now, what if you want to change the standard output? Say if I pull the deployments and I want to change some of this information here. Basically, I want to say, pull one column that has the image of the app, this app, the image that was used to deploy this app. Say if I want to include that, how do I go about doing that? And that's where there is a flag called custom columns that comes handy. This is the command. If I run this now, this gives me an output like this. The kind is deployment, name is math functions number wiki, the app name, namespace is this, and the image used is this. Now, how is all of this information coming out? Let's just unpack what we did here. Look at this output equals to custom columns. What this is doing is this kind is basically the header that we provided. And we said in this header, I want the kind dot name field. In the next one, I'm sorry, I need the dot kind here. In the next one, I need a name as the header, and I need the dot metadata dot name in here. The third one is namespace, and the value I need is dot metadata dot namespace. And the image, in the image field, I need dot spec dot template dot spec dot containers and the star dot image. And I'll show you how all of this is really working. So let's take this deployment. Let me just do a kgd app one and minus o YAML. Let's look at the output here. Now the first thing that we want to traverse is this dot kind. If you look at this YAML, the first field, that's the first field. So dot kind, it goes by this combination, this syntax. It needs that dot at the start. So dot kind is identifying what kind of a resource is that. So in our case, that dot kind, that is a deployment. The next field is dot metadata dot name, and that dot metadata, if you think about it, metadata, and under that metadata, if you look at everything underneath metadata, you will see this name, which is math functions. That's what you are seeing getting pulled here. Dot metadata dot namespace, that's the third field, that is ECP. And then this image, let's see, let's try and traverse this path here. So dot spec template spec containers. So look at this, dot spec dot template, and again dot spec dot containers. So we just followed this through till containers. Now what's going on with this star? That square bracket, basically that is defining that means there is a list underneath containers. A list basically is in Python terms, a list is an array. So basically there could be multiple containers, right? That's why that star. So currently in our setup, there is only one container running in this part. In service mesh or if you have Istio or ASM service mesh deployed on your cluster, then you will see a sidecar proxy, Istio proxy running in your pod as well. And that's the second container. So had that been the case, you would have seen two images in this output. One would have been this, the math functions image, and the other one would have been the Istio proxy. But that's for later. Just know that the star is denoting, okay, pull the images for all the containers within that deployment. Say if I want a different output, I can very well do this now using this. Say if I want a different output, then I just change the appropriate path and get the output that I want. Say in this output, I wanted the replicas instead of the images, or even both replicas and images. You would then modify the custom columns accordingly and get the output you're looking for. Now at this point, you can also include a field selector. Now you can apply, as you know now that you are able to traverse through the fields in the pod in the deployment configuration. You can go about now applying another parameter called field selector, and here is how you go about applying the field selector. In this command, I'm saying the field selector is go after metadata.name equals to app1, which is math functions, and give me the output that has kind, the name, and the replicas. And if I run this, I get just one row instead of the two. And if I remove the field selector, just take a quick peek again, the same command with no field selector returns two rows. There's one more format of output, and that's called JSON paths. Say if I run a command like this, minus o equals to JSON path, and then again provide the same path, traversing the same path as you saw in the previous commands, you'll get the output. Another example would be, say you're going after looking at the resources, and it gives you the output, but then I haven't seen this being used a lot, and I do not find the output in a very good format that I can readily use. But if you find it useful for the use case that you have at your hand, by all means absolutely go forward and use accordingly. Let's look at now how you go about applying or deploying Kubernetes resources using the Kubernetes config YAMLs. So for the two apps that we have, our demo apps, Math Functions and NumberWiki, I'll now show you the configuration files. On the right hand side, now let's take a quick look at the configuration files. I have three files in this folder: ns.yaml, numberwiki.yaml, and mathfunctions.yaml. Let's look at the contents of each one of these. Say cat ns.yaml. This is the configuration file for the ECP namespace. The namespace that we created, kgns, if I do here, this namespace is created using this. If I do a kubectl describe namespace ECP, all the information, but this is the information that namespace has, and this basically was defined from this configuration. We provided, this is the input provided to via kubectl to Kubernetes, and Kubernetes AGK basically created this namespace, and this is the information that namespace resource holds. Right, that's how this is working. So that's our namespace configuration. Now let's look at our app configuration. So if I do a cat math functions YAML, I'll scroll up and show you what's in there. So basically, look at these three dashes that segregates one resource from the other. So that's our first resource in here, and that's a service. The second resource here is deployment, and the third one is a pod monitoring resource. Ignore the pod monitoring resource for now. This is an advanced concept or needed for monitoring purposes to send some metrics to Prometheus. Not necessarily needed if you are at very beginning stages of running an app in Kubernetes. So look at these two. I'll cover the deployment first. That's the basic one. Deployment is an important concept in Kubernetes, and again, some of that will be in the Kubernetes session. But look at the specification of this. Basically, the metadata is the name, the namespace, and some of the labeling information. Spec is what really defines what kind of pods are going to be created by this deployment. So this is an important configuration. It says I need 5 replicas of my math functions, and that's exactly why when you see KGP, the pods running, you will see 5 replicas of math functions running, and that is because of this configuration that we saw here. We set replicas 5. In some of this selector, basically this is to really define or connect our services. So if you look at the service as well, there are selector labels here as well. Basically, based on these selectors, your service gets associated with the pods running in the background with this deployment. Again, some of these concepts you will understand as you learn more about Kubernetes. Another important specification in this basically is you're running the image. What image need to what containers need to be deployed in this. We have just provided, like I mentioned in one of the previous sessions, as we were looking at the get commands. There could be multiple containers in here. Currently in our configuration there is only one container, and these are the resource limits in CPU requests. So that's a deployment definition. This service is basically how you expose your deployment for being called from outside. Basically, this is saying this service will listen at port 8080 and it will forward the request to port 8080. That means if I hit this cluster IP, although this type is cluster IP, if we look at the number wiki, that's the service that we have really configured as a load balancer, and I'll show you that. Basically, this container is listening at port 80, or this service is listening at port 80, and this forward the request to the port 8080 of the container running inside inside the pods that this service is pointing to. That's a high level on how math functions is configured. We'll take a quick peek at the number wiki configuration file as well. The only difference I'll point out here is in this service, the type is load balancer here, not the cluster IP. And the difference is, if I show you the difference, if I do a KGS, basically pull both the services, you see this external IP, there is none for math functions, and that's because we specified that type for the service as cluster IP, whereas for number wiki we said load balancer, because we want this to be available to outside world to be called from, right? That's how the configuration is working. We'll now see how we go about deploying or deleting the deployments. So on the left hand side, see, currently I already have it deployed, right? That's how you're seeing all the pods running. So if I keep this on a watch, basically let this stay on the watch so that you see the changes occurring. What we'll do is we'll delete the deployment math functions here. Let's do this. So if I do a kubectl delete -f math functions v1.yaml. Let's see what happens. Look at what's happening here. It said service deleted, deployment deleted, pod monitoring resource. All the resources got deleted, and you're seeing that on the left hand side that the underlying pods are getting terminated. That will soon get terminated, and we'll see all of these 5 pods gone. Yeah, at this point, if I run the command kgp, as you just saw here, all the math functions pods are gone. And if I now say try and hit this external IP, now we know that this is in turn calling math functions. Sorry, this is number wiki external IP. If I do a curl this and 345, that is going to make a call to math functions service, but that fails, of course, because there is no math functions. It's trying to resolve this math functions.ecp.service.cluster.local, but that does not exist because there is no math function service in the cluster right now. So let's resolve this. What we'll do is we'll do a kgp watch on this side, and we will do a kubectl apply -f math functions configuration file, and let's see what happens. It created the service, created the deployment, created the pod monitoring resource, everything that is mentioned in the configuration file. And on the left hand side, you see that here the pods are coming up, and the container is getting created, and so on and so forth. So at this point, everything is done. If I do a clear screen and run a KGP, that gives me all the pods are up and running. So that's how you go about deleting the deployment, or creating or deploying using a kubectl configuration file. Here are a couple of other important commands that you will need to know from deployment standpoint. Say currently there are five pods, five replicas of math functions are running, and there are three. Say you want to scale down these five to three. What you can do is kubectl scale deployment replicas. Say I provide three here. Now before I run that command, I'll do a kgp watch here so that we can see the changes here. I'm trying to scale down the math functions. So from these five, two of these will get terminated, and it'll get down to running three pods. So let me just submit this and let's see what happens. So this shows you that two of the pods are getting terminated now, and if once that completes, the net state would be you will have three pods running for math function. Now, quick tip here. This is not how you do scaling up and down in production environments. There are better ways of handling this using horizontal pod autoscaler, HPA, but that's for the Kubernetes session. Here you have basically manually scaled the deployment down, whereas all of this is actually handled by the HPA in nicely run Kubernetes environment. So that's your scale. We'll see one more command here that is important. Let me run the KGP and KGP watch on the left hand side so that you can see the changes. I want to do a rolling restart. Say you are in a production issue and there is a need for then, and you did a hard fix in production, and you need all of your pods to be restarted so that the change takes effect. Something like that. What you will need to do is kubectl rollout restart deploy math functions. So when I do that, basically it will force all the pods to terminate and then come back up again. And that's what is happening now here. Let the process complete. It'll take a few seconds, and then we'll look at the final output again. You'll see that these eventually the pod names will change, like this 8cc 4tt, all of those will get changed. These were the old pods, and now if I do a KGP, so that's gone. So these are the new pods. Notice the last few, all of these are new ones and are not matching with what we had before. So this is how you do a rolling restart of your app. Now, I'll show you some imperative commands that I think you should know as we close the session on kubectl. So far we created all of our deployments on all these apps using our configuration files. That's a declarative way of creating your deployments and services, and the right way of doing it in production. While we are running the kubectl commands from our terminal using these configuration files, even that's not the right way, but at least we are using the configuration files. And of course, in production way, you will need to wrap this around a CI/CD and on all of that. Right? That's how you'll make it productionized completely with a CI/CD pipeline. But there are imperative ways. I can very well, run commands like create deployment and create, the deployments and expose some services. And we'll do that using our Nginx. Say if I want to run an Nginx web server on my cluster, here is how I go about doing that without having these configuration files like this. What I can do is I can do a kubectl create deployment Nginx. Say that's what I want to do, and I can also just mention the replicas. Okay, let's not complicate it. I will just create this deployment with the image nginx and call the deployment as nginx, and I will do a kgp watch here, and let's submit. Now, okay, there you go. Our pod is up and running, right? So there is an nginx pod is running right there. If I just do a describe, I'll do a pod kubectl describe pod, and I'll do a pod. It gives me all the information that you will need pertaining to this pod. Now, there is no way you will be able to access this pod yet because we haven't really exposed a service. Remember how we did expose this number wiki service as a load balancer, and that's how we have this external IP that we are able to hit from the outside world to call number wiki, and number wiki in turns called math functions. We'll need to do something similar, of course, in as an imperative command, because we do not have the configuration files. So what we are going to do now is I'll do a kgs watch here, because we are going to be doing a kubectl expose deployment and as type load balancer on port 80, and the target port is 80. Understand what this command is doing. I'll just hit this, and we'll then understand. We'll break the command down, and you are seeing this service coming up now. Let's understand what happened here. We are saying we want to expose a service which is of type load balancer on the port 80. So the service should listen on port 80, and the target port for the container running within the pods behind this service is going to be port 80. By default, nginx runs on port on port 80. That's why you see the target port as 80 there. All right, there you go. Now we have the external IP provisioned for our nginx server. Let me run kgs again. Now if I curl this, I should see the nginx default page. When I do, yeah, so there you go. That's your nginx page. I should be able to hit this from a browser as well. If I hit that IP, I see this welcome to nginx page, and that is a successful deployment. Now we want to do some cleanup as well. Maybe what I'll do is kgp watch, or before we delete, let's go ahead and take a quick peek at this workloads from our console as well. So if I refresh this, yeah, that's your nginx deployment, and that nginx deployment is showing up just fine here as well. Now what we'll do is, we have already watched it here on the left hand side. I'll do a kubectl delete deployment nginx. You'll see that pod getting deleted now. All right, so if I do, yeah, that's terminating. And if I do a kgp, yeah, that nginx pod is well, not yet gone, but will be gone soon here. Yeah, that's gone completely. But we still have the service. If you see that the service is still here, and now you see and realize the value of how these configuration files help, right? If I submit a single command, say kubectl delete -f and that file name, it deletes all the resources pertaining to that app. Whereas in this case, it is all manual. Now I am required to do a kubectl delete service nginx, and that's how my service is going to get deleted. Well, it just completed, and the service just got deleted, so we do not see the nginx service now. Let's now look at a few commands that are important from troubleshooting standpoint. Say if I pull all the pod names, and say if I get this in a variable called pod. If I run a command called kubectl describe pod and then pod name, you get a good, well formatted output that will help you troubleshoot in case of issues. So this is telling you that all the information pertaining to the pod, and important information is right here, the troubleshooting information, if you will. That is right here. If there are any issues with the pod, and you're seeing issues in production and the pod is not coming up healthy, if you're seeing things like that, then you will see some information here in the events, and that's what we are going to now do, and try to simulate on by having an unhealthy pod, and then see what kind of information you get here. Let's see what describe shows when there is a problem with a particular pod. So to simulate a problem, what we did is, you see this new configuration file here. This is called failed app.yaml. Let's take a quick look at what we have in this configuration file. If I scroll up, this configuration file has, basically this is creating a service and a deployment. Everything is same as the math functions. The only problem I introduced here is, look at this image. That is not a valid image. This is looking for, in my Docker hub, it's looking for an image named failed app with the tag latest. There is no image named failed app in my Docker hub. So this definitely is going to fail. And let's see what happens if we are trying to deploy this. So before deploying, let me run a KGP watch here on the left hand side so that you are able to see what happens. I'll do a kubectl apply -f, and the file that we'll apply is the failed app configuration file. Let's see what happens. All right, it's trying to create that pod, and let's see what happens. It's trying. Okay, eventually it failed. It failed with error image pull. Let me do just a KGP. I know that it tried and created a pod called this, but it was not able to get the container up and running, because of course with the error image pull, and it is showing you 0 of 1 containers within that pod are ready. And if I pull the KGD and look at this failed app, even that showed 0 of 1. Basically we have we said there should be one replica for that app, but there are 0 running. That's what that 0/1 is. And in the pod output, the 0/1 means 0 of the 1 container expected is running. And now let's do a describe on this pod and see what kind of output do we get. If I do a pod name in that field and do a kubectl describe pod and that pod name, if you scroll down, you will see these events, and these events will tell you what's going on with the pod. It was trying to pull that image and it failed to pull that image, and hence the error. This is how you go about doing some troubleshooting using describe. The failed information, some of this troubleshooting is available on the GCP console as well. So if you look at the workloads on GCP console, you see that this failed app is showing with does not have minimum availability. Of course, it does not have minimum availability. The minimum availability is 1 pod should run, but there are 0 runnings. So there is a problem. If I click on that, you will see some warning signs here as well that really tells you what's happening. It gives you some information here as well. So GCP console as well provides you a lot of information, troubleshooting information that you should be able to tap into. Another important troubleshooting command is kubectl logs. You can look at the logs from the pod. So if I do a kubectl, let me just pull the log for the pod names first. Let's try and look at the logs from this failed app pod. If I do a pod equals to that guy, and if I now try to run kubectl logs and that pod, it gives me an error, of course, because the failed pod is not even running, right? So there are no logs at all for this. But now let's look at the math functions log, this guy's logs. So if I do a pod equals to that, and let me do a kubectl logs, and that minus f is basically you are following along, so it will keep showing you the logs, right? So now if I you know that math functions gets called from number wiki. So if I hit number wiki, then it will in turn make calls, and hence we'll be able to see some. Now notice that there are multiple pods, so our request might or might not hit this guy that we are watching, but let's see. So we'll do a curl on this with a particular number. So we'll do a curl on this and we'll choose a different number here, 457. All right, let's see. So yeah, so this request, yeah, you saw some requests. So look at this 457. There were only 3 requests coming that came to this pod, whereas the other pods, the other math functions pod did serve the other request. We know that number wiki, one call to number wiki makes like 14 calls to math functions. So I'm seeing for this 457, I'm just seeing like 3 calls here. So I'm sure if I do kgp, and if I do the next pod like this one, let me call this pod 2 equals to this. And now if I do a kubectl logs pod 2, yeah, I see some of the 457 requests are served by this pod. Now, similarly, let's look at the pod 3 as well. If I do a kgp, look at this number 3 pod, I will call this pod 3. And now if I look at the logs for pod 3, yeah, a few of 457 requests are here as well. So we just saw that all the 14 requests, math function pod requests, are handled by different pods here. So that's how you use kubectl logs to really see what's going on. The other one of the other important commands is this. So indeed, if you want to just log into your pod, this is how you do it, and I'll show you that alias first so that you see how and what the actual command is. Kubectl exec minus t minus I. So if I do a kubectl pod bin sh, that bin sh says that you are trying to start the process in your bash shell. So if I do a pod 2, I know that a good math function pod is in that pod 2. If I do this, and I am logged into the pod. If I do an ls, all of this is the application code that for math functions. If we do a cat on say main.py, you will see that all of this is our math functions endpoints. It's listening on port 8080. This is the Flask template code for the math functions main.py. So this is how you use your troubleshooting commands, the describe, the logs, and exec. Here's the recap for what we did today. We connected to the GKE cluster and set the context. We went about seeing how you can help yourselves as you start working in kubectl. We looked at various options available in kubectl help. We played a lot with kubectl get, like we pulled the information in various formats in JSON, YAML. We looked at custom columns format. We looked at JSON path for all deployments, pods, and services and whatnot. We looked at how you go about deploying the apps in a declarative way and then in an imperative way as well. And finally, we did a lot of troubleshooting with describe, logs, and exec commands. Well, that brings us to the end of this video. If you like the content, please do subscribe the channel and hit the bell icon to get notifications when new videos are posted. If you're genuinely interested in learning all the foundational skills around SRE and platform engineering in general, stick around on this channel on Everything Cloud Platform, and follow along all the videos that are posted. I'm sure you'll find value for your time. Hope you had a wonderful time, and I will see you in the next session.